Today we're going to talk about units in scientific notation, which hopefully will both be a little refresher for you. And we'll start off with some scientific notation. So what is scientific notation? It's just a way of writing very large or very small numbers in a more compact way. And we'll use this quite a bit in chemistry, both with large and small numbers. So make sure you can go both ways and you don't have questions in going either direction, either into long form or short form. Scientific notation represents a number by taking a base, which is any number between 1 and 10. And when I say between 1 and 10, it's never a value of 10. It will always be less than 10. And you'll see, if you don't remember, why that is when we start to write the base multiplied by some power of 10. So here's our first example. And our base has to be a number, again, between 1 and 10. So in this example, we'll go with 5.6. And to get to that 5.6, which means my decimal is moving clear over here, if you see where my arrow is, I'm going to have to move it from the end of the number down here. So I would be moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would give me 5.6 times 10 to the 10th. Another way you see that makes sense why we're using power of 10 is you see all those 10s lined up there. That's 10 of them. We moved our decimal place 10 places, right? So 5.6 times 10 to the 10th. So that's a very large number. Let's take a look at a very small number. So our base here again will be between 1 and 10, so 6.3. So I'm going to move my decimal all the way between the 6 and the 3. So I would move it over 1, 2, 3, 4, 5, 6, 7, 8. And the difference here is that I have a very small number, so my decimal is going to move to the right, which means my exponent will be negative. Right? So that would be 6.3 times 10 to the negative 8th. And you guys will see on the next slide, right, that my exponent being positive or negative indicates whether I have a very large or very small number. So large numbers, I have a positive exponent. Am I moving my decimal place to the left? Small numbers, I'm going to have a negative exponent, and I move my decimal place to the right. You see a couple examples up there. If you want to pause, count the decimal places, make sure that your understanding is ready for class tomorrow. Here's some practice. I encourage you, if scientific notation, if it's been some time or you feel like you have not seen it a lot, go ahead and hit pause now, practice on a scratch piece of paper, and then unpause it to see the answers, because I will go ahead and reveal the answers to A through E now. And again, hit pause for a second if you want to check your answers. So calculations with scientific notation, the real mastery on this is just entering it correctly in your calculator, to be quite honest. So again, go ahead and pause, take a second, enter them into your calculator, and now I will show you the answers so you can check them. If your answers aren't correct, please take a minute in class and we'll look at your calculator together. I'd hate for you to lose points for entering something incorrectly in your calculator. So the last slide was addition and subtraction. This slide is just practicing with multiplication and division. Again, pause the movie, take a second, enter them in your calculator, and now I'll show you the answers so that you can check them. On the division ones, if you notice that your base is the same as mine, but your exponent is different, right? Make sure that you're using parentheses to preserve order of operations in your calculator. Right? This entire number often needs to be within parentheses so that you divide by the whole thing rather than dividing by just the 2.75 and then multiplying the whole thing by 10 to the second. Right? So preserve those order of operations. So units. Once we have numerical values, we need a scale or a standard to say what we have. Right? Because if I said, oh, I have 1, you don't know if I have 1 ton or 1 gram, right? Where a ton could fill up our entire classroom and a gram can sit on your balance in lab, right? So we really need a unit to let us know what we're looking at, what we're comparing. So there's two common systems of units. Right, there's the English unit and there's the metric or SI unit. It's already bolded, screaming out at you. In chemistry, we will use the metric or SI unit. SI just means the International System of Units, right? Just like the metric. So as I hinted at before, right, units are so important because they allow us to really make a quantitative measurement. So when I say quantitative, just as its root quant, right, it's a quantity, it's a value, generally numeric, right? We want to compare grams to grams, tons to tons, right? We want to make sure that we have that standard. So some common units of measure are listed up here. Length, mass, volume, and temperature, right? We will commonly get these quantities in lab. And the units listed there are the base units that go with the prefixes y'all will see on the next slide, right? The meter, the gram, the liter. Temperature, you see 2 there. That's because your thermometer will measure in Celsius. It actually measures in both Fahrenheit and Celsius, but don't forget Fahrenheit is a bad word in chemistry. Don't ever click your thermometer to the F. We will always measure in Celsius. Some units will convert those Celsius to Kelvin to make our calculations accurate, right? But we'll always measure in Celsius. I've given you a little description, right? Mass, how much there is, volume, how much space it takes up. Temperature is probably the only one that's new for you. It's really a measure of how fast the particles are moving. We'll talk much more about that when we get there. Right now, we're just really familiarizing ourselves with the units that we must always attach to our numerical values. So, again, the meter, gram, liter, and Celsius, Kelvin are just our base units. A great example of how we'll have prefixes come in here is y'all already saw in lab. Most times that we measure volume will be in milliliters, right? That liter's the base unit, milli is the prefix. So we, again, on the next slide, we'll familiarize ourselves with those. Common instruments, you guys have already done a lot of great work with the instruments, but length, the meter stick, mass, the balance, volume, the graduated cylinder, and temperature, the thermometer. So these prefixes, I know this slide has a lot going on, but so the prefixes names are listed there: giga, mega, kilo, deci, centi, milli, micro, and nano, are listed from greatest to smallest. Their symbols are there, and the symbol just goes right in front of the base unit. And if you look all the way over to the right in the example field, you see, right, if I have a giga, you just see the capital G in front of the gram, right, a gigagram. Same with mega, kilo, deci, centi, milli, micro, and nano. Right? That just goes in front of my base unit to describe that. Again, the milli, liter, we've already seen. My example here is the milligram. So as far as our conversion between my base unit and my prefix, you'll see just going in order, 1 gigagram is 1 times 10 to the 9th, or you could simply say 10 to the 9th grams. Right? It's because that unit is so much bigger, I have 10 to the 9th grams of them. If you have questions on how these prefixes play into the value, please ask me if it is unclear from looking at this slide. We will talk about this in class when we do conversions, right? So if that doesn't reinforce the idea and you still have confusion there, please stop me and ask, because we will see these prefixes throughout the year, which leads me to, yes, you must know them, right? Make some flashcards if you want. Y'all know that I always have note cards in class you can make flashcards with, right? But take some time to really learn them, because you'll see them all the way until May. Y'all have a great night.